This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Seberg. Good morning, Robert. How are you doing today?
Today, I'm very fine because we are celebrating 300 episodes of the Industrial AI podcast. Congratulations, Peter.
Oh, that's amazing. 300. How long ago was that?
6 years ago. Yeah.
6
we
years,
started.
I believe, yeah.
Yeah, 6 years ago we started.
Amazing.
And we are not alone today. I would like to welcome Mr. Industrial AI, Boris Scharinger in Munich. Hello, Boris. Welcome.
Good morning. Good morning, Peter. Good morning, Robert. And also congratulations from my side.
Yes.
Applause, applause, applause.
We are really looking forward to that.
Thank you very much.
Thank you.
Boris.
Boris, for those who don't know you, please introduce yourself briefly and then tell us what was your favorite episode.
Yes, so my name is Boris Scharinger. I work in Siemens Digital Industry CTO office as an innovation scout and, technology scouting, startup scouting, and also a little bit of industrial AI ecosystem work.
You are Mr. Industrial AI, I would say.
Thank you. And my favorite episode, the episode that really drew me into your Industrial AI podcast was certainly the session on federated learning and injection molding that you did with
Werner.
That was with Werner and that was with Michael from Cthulhu.
Oh, yeah.
Both of them. Because I looked at it and I saw, wow, these types of concepts and ideas and platforms not only make a difference on the productivity side of life, they are also designed and defined really with needs of industry and requirements of industry in mind, and the topic of confidentiality and using federated learning to address the fact that no one wants to see their shop floor data leaving the shop floor. That resonated a lot. And I even took that episode and the transcript of that episode and did the bloody work, I have to say, to straighten the transcript a bit and translate it into English so I could send it around to some of my technology colleagues. And
it was still a German episode, right?
That was still a German episode,
Okay.
yeah. And I thought, federated learning is so powerful, let's look at it.
I recall the central theme was the data are not coming to the algorithm, but the algorithm is coming to you, right?
Exactly.
Is that topic federated learning still a topic for you at Siemens? Because we already talk about foundation models, few-shot learning. You don't need so much data anymore. What is your opinion on that, Boris?
Oh, that's a difficult one. First of all, it is a technology that is very powerful, but also complex to master. So you need to go through an additional learning curve to master federated learning, while wide parts of industry are just going through their learning curve to master machine learning at all. That's one aspect of it. The other aspect of it is that the foundation models and the power of large language models really turned some aspects of the business case, the return on investment calculation, upside down, in a sense that in several areas there is so much pull from the productivity potential of large models that the people who were slowing things down, saying, hey, wait a minute, we need to address the confidentiality issue first before we really can work with AI, have been almost overrun by those saying, no, there's no way that we don't address generative AI usage and that we don't run for the productivity potential. So the focus has shifted a bit away. There's so much enthusiasm in making generative AI work that the confidentiality shop floor topics are a little bit, in the background. I still see it coming. It's just a matter of timing.
Boris, can I jump in there? As Robert already suggested, you for us are Mr. Industrial AI. At least you are Mr. industrial grade AI. Maybe you want to just remind the listeners exactly what the industrial grade means, different from just, AI that people are doing everywhere. And then I'm going to follow up on the question, is Gen AI, which, it came up during these 6 years that we've been doing this, is Gen AI or large language models possible within industrial grade?
Yeah, great questions. So when I started to look into the technology field of AI for industry, that was kind of 2019, 2020. First of all, within Siemens, I found out we have so much AI expertise. We have so much talent, and they are working in different teams, close to products and building features and so on. But we were at Siemens not recognized for our capabilities in the market as an AI player. And that's when I looked at, where is AI? How is AI perceived? Where is AI really gaining momentum? And it was clear it is all around social media, commercial ad placement, financial services, where a single use case addresses a huge commercial potential right away, easily. In most cases, because the data situation is a lot easier to sort and to solve than in the industrial space. And when you try to take whatever has been produced by the B2C markets, AI frameworks and so on, you would immediately hit a wall. And you have to go through so many different aspects of maturing AI, maturing the data pipelines, getting your data straight. And it doesn't scale so easily. Yeah, it must be better hardened, more robust, more reliable, achieving the 99 dot something % of a hit rate, right? And then at the same point in time, the work is a lot more cumbersome, not necessarily great tools in place yet. And this is when it really got me that AI needs to be different, have a different flavor. And it's a journey to go there. Everyone was talking about how difficult it is to get an autonomous car on the road, performing well. No one was talking about how difficult it is to get autonomous machines and autonomous automation processes in production sorted with AI. But the challenge is a very similar challenge when safety is touched and essential, and also when you need to work towards those 99 dot something hit rate.
Mm-hmm. How has the view of the whole sector of industrial AI changed from your point of view? What are your observations looking back 6 years?
First of all, generative AI, and I don't forget your question, Peter. We come back to the topic of LLMs and industrial grade in a second, yeah. But of course, the arrival of LLM technology has changed the perception of AI a lot and made it an integral top priority item on every CEO's agenda. And this helps in a sense that you see many companies starting into
What is on the agenda? LLMs or also good old-fashioned AI?
It is generative AI.
Yeah.
But the fact that there is a lot of investment, there are, many startups, there's a lot of venture capital, and every company is willing to enter the learning curve prior to looking at the return on investment of one particular use case. This obviously helps also the other disciplines of AI.
Mm-hmm. So coming back to Peter's question.
Exactly. So can we get LLM technology and industrial grade AI together? So when you look at industrial grade AI, it is not sufficient. It is not enough to just look at model qualities. You can look at AI models and talk about universality and robustness and attributes like this, but you have to really to look into the whole stack. You need to see, is my execution environment industrial grade? Is my edge environment capable to run it? Or is my cloud environment hardened to be protected against misuse, against data slippage, against cybersecurity threats, and so on? Is it manageable? You need to look at your hardware. My favorite example is if you take an NVIDIA gaming card and put it into an IPC, it will die soon. you need to have industrial grade hardware stack. You need a hardware stack that is supported over many years. If you build a production line, that production line is supposed to run for 10 years. There is no use of using AI chips in a production line when the end of life of serviced and supported life of that AI chip is 3 years. You need to find technology that is supported 7 years to 10 years, right? These are all examples where industry needs a checklist and have to go through the elements of what is really needed to make it work for me. What's the user experience? There is no sense of having data scientists designing a user experience that then will hit shop floor workers. I need to have a user experience that is strongly focused on the people using the AI systems in the end of the day. And now I even, didn't touch the topic of data, right? And how can you make data work? You are so familiar with OPC UA, pardon me. But then what is the degree, what is the rollout status of OPC UA? How many companies have, consistently rolled it out as of today? So these are all questions that really influence how mature and how robust your AI system works. Not talking about ML ops and application integration, that adds even on top of that. So now coming back to Peter's question, LLM technology seems to become almost a commodity as such, right? We have several language models, smaller ones, larger ones, that are performing sufficiently well to cover the idea and the concept that users can interact with systems, with IT systems in natural language. That's great news. However, if you don't pair LLM technology up with industry-specific domain knowledge that you may capture in specific RAG layers, that you may capture specifically in knowledge graph technology, then you don't achieve a level of quality that is accepted by users. It is, interestingly enough, always causing a wow effect in management. So if you do a demonstrator, you upload 100 documents to ChatGPT that may relate to your machine, and then you present that chatbot that will answer questions about the machine using that documentation. Everyone goes like, wow, we wouldn't have ever thought that this is possible that easy. However, if you hit an engineer using AI in daily life for engineering, or if you hit a shop floor worker using that solution in the daily life, they cannot accept a 20% hallucination rate.
Absolutely.
They really need to have 19 out of 20 answers correct. Otherwise, they reject the solution.
Boris, maybe I'm wrong, but that sounds for me that you and Siemens are totally focused on LLM technology, or am I wrong?
No, we
What
are not.
about the good old fashioned?
No, there's a lot of stuff going on in classical machine learning, whether that is machine vision or time series analytics, but the semantics of these expressions become a bit blurry. If we look at generative AI and then you use generative AI because it is step by step incredibly getting almost perfect in image analytics. I can upload a picture of a bin, a metal box, into ChatGPT and ask about it. And it will actually say, I'm looking at the metal bin. I'm looking at, I can see scratches in the surface and I can see 5 holes, obviously, from drilling. So this is not industrial yet, but this is an example where generative AI is not generative any longer. It becomes analytical. Funny thing, right? And then, Robert, you from your background, that technology that we would categorize under generative AI is now used for time series analytics, right? So where's the point of continuing to call it generative AI?
Exactly. We already had an episode with Richard Zocher talking about Gen AI LLMs become a crucial part as an operating system. What is your opinion on that?
That is certainly an interesting thought, and I can relate to that specifically for all of the use cases that Richard is looking at, which is knowledge worker use cases, right? If I do a competitor analysis, or if I do, my field of expertise, a technology field analysis. And I really need to drag venture capital investment statistics, job requisitions and offerings in a certain area, patent development and activity in a certain, and I need to put it all together into a 20 pages report saying, where is quantum computing going, right? Then obviously the times that this is done by Google search or by using 5 different logins into 5 different databases and manually aggregate those pieces of information together, these times are over.
Yeah.
And I think that's what Richard means.
Okay. But Boris, maybe you can share which episode made you think, okay, I didn't know that. This is interesting. This is a totally new angle. And why? Oh, I need to try that out. Or I don't agree, but it's an interesting opinion. Do you have an episode?
From my perspective, there are many episodes that touched me or influenced me, right? The not so easy discipline, I think we once called it beast of reinforcement learning.
Oh, this was with Jan, yes.
With Jan, for example.
Yeah.
But we also had it in the hydraulic space. Remember that episode? That was catching my attention. And then I was really impressed by the episode on using AI-supported generative design in the yachting area, in the shipbuilding area. I'm fascinated mostly by AI applications that change product design fundamentally, in a sense that it becomes much more resource efficient, much more sustainable. If you make a difference by generative design on how ships are designed, how much water resistance, how fuel efficient they are, right? This is changing industries for a better. And this is what really impresses me. And of course, many of you look at Siemens and Siemens Digital Industries as someone who supports production, right? With many shop floor applications, and robotics and machine vision and the PLC business. And I love this too, but the power of starting earlier, software in engineering, simulation, industrial metaverse even. I mean, that would be worth an own episode of what the industrial metaverse is and why it is so strong. This can fundamentally change how we build products and how sustainable they are, and then hopefully lead us into a better future.
Talking about the future, Boris, that's going to be my final question. Where is the future going? Now, I'm going to expect that you're going to tell us that we should be telling you. That's our job. And Robert and I, we do make our own agenda. We typically have like a 6 months calendar in front of us. Nevertheless, very much looking forward to hear from you. What do you see as the big topics? What would you love to hear Robert and me talk to people about in the next couple of months?
That's an interesting question, Peter. And you will probably smile if I tell you agentic AI.
That's Peter's topic.
Exactly, right. Agentic AI being an orchestration layer across AI agents, but also across non-AI agents. So the cumbersome work of creating and designing, implementing, and then optimizing business processes, workflows in companies will eventually become a lot easier by the powers of agentic AI. Now, I still believe there's a lot of quality management and assurance work to be done, but I find these concepts to be very powerful. We probably see them in other industries implemented first in industries that are a little bit more transactional and a little bit more simple than, manufacturing, discrete manufacturing process industries. But we can see so many demonstrators and even first implementations where you could understand and almost grab the powers of agentic AI. And then the second topic, I touched already, AI for engineering, to speed up, to accelerate, to extend simulation to fuel AI. So there are a lot of interactions between AI, the digital twin, the industrial metaverse, and then using all of that for building better products more efficiently.
Boris, I have good news for you, because in the main part, Robert Gomez is waiting for us from Clevertist, talking with Peter about his WinCC agentic approach. Right, Peter?
Exactly.
Yeah.
And it's spot on. So that's
Yes.
of the two main areas that you expect. We're delivering one today on the Thursday when we go live.
Perfect. Chapeau to Bobby, and I'm so happy that he joined our AI with Purpose Summit and presented what they have to offer.
And on exactly the same day that you are going to be joining us as well. Boris, thank you very much for the support that you have given us, Robert and me, over the majority of the
Thanks a lot.
6 years.
Yeah.
Looking forward to be cooperating with you further, and looking forward to have a great day in the Alps at this very day that we're airing this podcast. Thank you.
Thank you, Boris.
Thank you to you, Peter and Robert. The ecosystem work and community work that you are doing around this podcast and with this podcast is vital to, how we cope with the challenges of industrial AI and how we mature it.
Thanks a lot. Boris, bye-bye.
Bye-bye.
Thanks, guys.
Peter, bye-bye.
Bye-bye. I'm here at the Siemens AI for Purpose Summit, and opposite of me I have Robert Gomez Reino. I hope I pronounced that correctly, from company Clevertist. And you just did, that is about half an hour ago, you just did a presentation, and we're just going to be talking about it. The title says WinCC OA, Industrial Operator, an autonomous multi-agent system. And the listeners know that I am very much interested in exactly both of those two elements, the autonomous and the multi-agent. So why don't we start, Robert? You introduce yourself to our listeners.
Thanks for having me first, Peter. I've been listening to your podcast, and I really wanted to have this conversation at some moment with you.
Very good.
Just to give a very quick introduction of myself, I'm a physicist. I work at CERN over more than a decade developing industrial control systems for the LXC experiments, where we gather really a lot of experience on very large systems that didn't exist back then in industry. We are starting to see this sort of size of systems and complexity emerging now. And yeah, back then, about 10 years ago, when we already discovered the Higgs particle, and I saw the opportunity to bring all that knowledge together with a small team and create the company to actually address those challenges of bringing these novel techniques and approaches and methodologies that we develop at CERN for those systems, since we needed to create them pretty much from scratch and bring those to industry. And we've been the past 10 years addressing the industrial market from that perspective of managing life cycle of complex projects, trying to digitalize, integrate large systems in ways that you could, whatever you wanted to do, in fact, you could do it in a fast way, and you could evolve your system quickly. And it happens to be the right choice and the right approach, since as we can see over the last 2 years, we're in the face of a fundamental change where, rules are changing, everything is moving extremely fast, and the opportunities are becoming very important thanks to the generative AI.
Right. You mentioned the word fast a couple of times. Now, coming from CERN, which maybe you want to spend just 1-2 more lines on it, but as you said, it's like, finding out particles or doing experience things with particles. And if we say fast, and then you move to industry, and sometimes we have fast or faster protocols, but it's very, very slow. Yes, I was going to ask you, but let's stay there for the moment, yeah, right?
Yeah, it's funny, you're totally right, Peter. Our systems, so industrial control systems at CERN, are usually referred to as slow control. So what is this sub-second, which is what we do actually for these industrial systems, is considered really slow control, because collisions are happening at 40 megahertz speed, so there are millions of collisions happening in a second, and the data recording is completely working in a different dimension, if you want, of time. So from our point of view, I was focused. While I was there, sure, I did my PhD in physics, so I focused in the physics part, but most of my work was in fact dedicated to prepare those industrial gigantic experiments to perform the data position, and that was, we call it slow control. Now,
so you really wanted to slow down, kind of, when moving into industry. Okay, well, very good. So tell us more about it. What have you been? You've been developing product. You've been developing service. What is the type of markets that you work in, and then slowly move towards?
Well, we always realized that initially we wanted to bring a lot of value to industry. We saw the opportunities, and of course, coming from CERN, we thought all of the things that we could build. But the challenge when we arrived to to the reality of industry is that we found systems full of legacy silos and as you know, sometimes outdated approaches and so on. So we realized that there was already a very important task to do, and at the same time an opportunity for us in building framework, if you want, to streamline the development of those systems and convert those sort of legacy systems in something that could be much more dynamic, like the modern IT systems, which they are updated pretty much weekly. Currently, we are working together with Siemens Energy. We work for a lot of Siemens companies and Siemens OEMs, and we are working very close with Siemens Energy now. And we've developed from scratch this system for multi-utility, multi-power plant control center. And we are able now, currently in the phase of development, while they are operating, to deploy weekly, to do deployments to production weekly, basically. So we have really a full life cycle control of the system, which the customer is hyper reliable, and because they can see that they actually get all these new features, and they are able to. This gives you a new degree of thinking when you are the operator of such system, because now you know that you can do changes and you can adapt much faster than before. Before you knew that the commissioning was something very heavy, that changing my system was something complex and takes time, and I have problems and I need to roll back. And now they are confident in the system, and that's one of the reasons why this operator actually picked us to bring generative AI into their industrial system, because they see this opportunity.
Right. So is that a typical, customer environment that you work in? So it's the utility, energy, process, maybe more in general, more than discrete manufacturing?
I would say that our knowledge is transversal, and we always propose it like that. So what we do is applicable to all of the sectors, and the proof of it is after 10 years we have worked with all of the probably different industries that you can imagine. So we do a lot of infrastructure, but we have manufacturing, we are in research, we are in transportation, we've been in metro. In fact, we also work with Siemens Mobility. We developed the digital station manager, the first versions that we collaborating with the Brunswick team. So we've been a little bit touching, and always, of course, we become domain experts when we work petrochemical. It was our first project, and today we are domain experts in the petrochemical sector. But when we start, we are bringing other type of value, which is how to build these adaptable systems, how to manage the life cycle.
I mean, that is kind of maybe also why I ask. I mean, because I have been like I think I called myself like a program manager for, at that time, discrete, and on the other side of the table was the program manager for process. And at that time, there was a very hard kind of, he was in charge of his and I was mine. And I think I've said it before, one of the listeners may recall, I think the overlap was like when producing water or Coke, that's the process, and the time it's being filled into the bottle, I would take over, that kind of thing. But maybe that is the question then, is that with the approach, and that's what we want to talk about, with the agentic approach, autonomous multi-agent systems, maybe that very specific, very deep knowledge of the specific market segment is less important than in the past? I don't know.
Not necessarily. I think what happens is that we are not focusing on bringing that knowledge. We are relying on or either our end customer or third parties on bringing that knowledge. So the systems that we are building, and I think you pointed to the two important axes, which is the agentic thing, but also autonomous. And autonomous is a very important one that we believe that very few people are still addressing. We are trying to develop systems that behave like humans, and humans are full of sensors, and they do things based on events. That's what I always say. So we need to create these systems that they are capable to react to event changes. And by the way, these control systems are the perfect proof and even benchmark for AI labs, in my opinion, to develop those new systems capable of these autonomous interactions. So we focus on those aspects which are if you want, a bit more abstract and independent on the domain knowledge. And we collaborate with the, in this case, it could be a power plant, for example, but it could be also a manufacturing line where they are putting in their specific knowledge.
Maybe you want to give us an example. Let's stay with industrial, more like, the production line. Where are you at the moment? When did you start with this idea of autonomous, and where are you there, maybe with specific use cases?
Yeah, I think the most specific one and the one where we are the most advanced is this infrastructure. So it's really multi-utilities. And currently what we have tested already very successfully, and that's why the customer is already engaged for the next phase, is a system that is very similar to what you could see today. In fact, and what we could test it is that the AI could streamline the start of a power plant, which is relatively a quite complex process, if you want. Of course, a lot of people that they are not used to this infrastructure could think that you just push a button and a power plant starts. Potentially, they were designed with that intention, but the reality of these systems is that there are many subsystems.
It depends on the type of power plant as well.
Probably
is
these
that
are
right?
gas
I'm not
turbine.
sure. Oh, this is a gas turbine. I just read about the thing that happened in Spain, and they were saying
not related to our system.
What system came up actually. But please continue.
Yeah. Exactly, and eventually these plants were not even designed to be turned on and turned off when renewables come in and out. And now they are doing it very often because, of course, renewables and solar and wind stop towards the evening.
So please make the comparison. So today there is not a single person. So there's a team of people. And where are you moving to? If you say you're moving towards making this power plant go live autonomously. So what is the structural difference between those two situations?
So you can probably imagine, to give you an analogy, you can imagine that, let's say 10 power plants, and you have a team of 3 operators continuously rotating with very specific domain knowledge. It takes years to learn all the specific things. Of course, when they commission the system, everything works flawlessly, but then things age and so on, and some systems have to be tuned or regulated manually, or no one thought about this. So they have quite some knowledge. And now you decide that, well, since they are all gas turbine power plants or renewable power plants, let's bring them all together, which is a smart approach to a single control center. So we can monitor all of them, and instead of having teams of 3 operators, which are many more because they need to rotate and take holidays and these things, not like artificial operators, and you want to bring them to a control room, and instead you're going to have only 3, maybe 4 operators instead of operator turns, let's put it like that, but just to compare. So you're reducing from 10 to pretty much 1 in that case. However, what happens at that moment is that, of course, there are peak loads where these operators might get overwhelmed because they have too many things to do at the same time. They have some processes that if you will look at them, you could almost think, why is this thing not automated? Because I have to increase the pressure and maintain it here, and you see that they might be needing to do something manually during 15, 20, 30 minutes and so on. And there are things that you could delegate to an artificial intelligence agent or agentic system, let's put it like that. So these are the kind of things that we see that we will be growing. We have tested it. We see how impressively some of the frontier models are behaving, how they want to use tools, how we are providing verifier tools so they can really validate what they are trying to propose, self-reflection, and we are using all of the if you want, frontier research to address these issues.
Yeah. And I recall specifically you today, maybe you're at a stage where maybe many times, typically, you still ask the operator, I am the agent and I'm making the following suggestion, please confirm. And I think you were suggesting that is until then at some point in time, maybe even the operator is going to say, with this agent, I'm perfectly happy. With the other one, it's less. Please, is that
well,
the way to look at it?
I would say 2 things here is, I think more than the exactly which agent or model or what is behind is perhaps for the moment the type of process. So there are some processes where that it provides a reliability that's comparable to human level. However, you don't need to be doing it, and that it could make a mistake, but also the human that is usually doing that, it could be making mistakes in similar rates and so on, and it's not a critical part perhaps. So at the end of the day, it's an economical probably analysis that you say, well, what is the rate of failure that I can have here versus having an autonomous system instead of the time of a person, which is much more costly in that case.
I recall that we were, Robert and I, with Boris Schanger, who is one of the organizers here of the event, I believe in Hanover Fair, and Robert, and he was questioning questioning like, are these AI-based systems going to be, approved at all? How is the regulatorily system? Is it today possible, or does it need to be within, let's say, a sandbox kind of testing out? And do you and those that want to provide these systems need to widen up and bring in the regulatory people as well?
Regulatory people are definitely involved in, especially in when you talk about critical infrastructure and IT security and everything. All related aspects have been some of the slowest, but there is a reason for that. So comparable to how fast we are developing now, how capable the systems are becoming, that part has been quite slow, full of approvals, and I believe it will continue being like this, but this will be like in 10 years when people will be banned from driving, right? You will be saying, look, 20 years ago we were driving by hand, and people say, the young people will say, you were crazy, how could you be
driving? Asimov here.
A little bit of Asimov.
Sally is the quote unquote, yeah. They called it fascism and everything, but in the end it stopped the killing. I believe that's the quote. Very close to him there. So in the end, the companies that you work with, your customers, they are looking forward to, because, that is the question. I mean, 5 years ago, whenever we talked about deeper, higher automation, we would say, oh, we're very sorry because, certain people are going to lose their job. But I assume that is not necessarily the situation in which we're in today.
I think, Peter, we have today a fantastic talk by Professor Niels. I don't know if you could listen to it, where he was sharing uncomfortable truths and inevitable truths. I think it's difficult to address. I think there is a challenging, perhaps, future for some people. I think there are some questions that they become difficult because they are not popular, and when you raise the questions, they become tricky. But I think we should address them, and I don't know if it's the level of policymakers or even all together as a society, but it's indeed, what Professor Niels was sharing is really happening inevitably. There's going to be a day where we're not the smartest guys in the room, and we need to think what we are going to do and how we are going to cope with that. And you can get into a lot of, which I consider a little bit delusional thinking sometimes, where people say, look, but reskilling, we can just reskill, there will be new jobs. But what makes you think that AI that is getting better and stronger is not going to take all those new jobs as well, and all that reskilling that you're doing for? So I must confess I don't have enough time to spend on thinking like that, though I think it's a very interesting topic, but it's complex. What we know currently is that we are focusing in providing more productivity and streamlining human operators, also because that's the capability that the current models have. We still need, but what is true is that while we are not going to see replacement of one person by one AI, what we will see is that groups of 10 people plus 3 control rooms, 30 people, will be replaced by much less people together with AI. And that, if the demand remains stable and the productivity is much higher, there is a mismatch between demand and offer, and that will translate eventually on less job as we know it. Let's put it like that.
But not necessarily in a negative sense. It's as
Absolutely.
far as my experience is, because just, there
we can call it liberation from job,
say
in
this
fact.
Is the end of my working life, and, now I'm going to be doing something else. And so I think there's a great opportunity. Maybe a final specific question. In your title, it says WinCC OA, which I hadn't heard about, which I assume is maybe a Siemens product. But I did ask a Siemens person, I'm not going to name names, and he also wasn't necessarily. So what is exactly that product, and how is it related to, is it on the basis of you being able to do autonomous multi-agent software?
Not really. WinCC OA is a product that was developed by a company called ETM in Eisenstadt in Austria, and it was acquired by Siemens. I hope I'm not saying anything wrong, but probably 2007, 8, in that range. And it was renamed. It used to have a different name. It was renamed to WinCC OA, and it's a product which is used for. In the past, it was most focused in everything. In fact, it's a SCADA. It's a multi-purpose SCADA. They say now SCADA Plus, because you can actually build even your own custom mini or light MES on top of it, and it's used it's owned effectively by Siemens, and it's used all over the world in multiple projects, and including Munich metro here, where we are, is the highways here as well.
Maybe I should have heard about it.
We have
Peter
power
doesn't
plants.
know about
It's in manufacturing,
WinCC.
in manufacturing, in many other sectors. It's mostly is more probably in infrastructure. CERN used it, and that's why we have some of the world-leading experts in that technology. So we started to use it even before Siemens acquired this company, and back in the 1999 or something like that.
Robert, thank you very much. We need to come
Peter.
to a close here. Thank you very much. I'm going to take away that at some point in time, we're not going to be the smartest persons in the room, and we should better prepare for it. You are preparing for it. Those listeners that want to get in touch with you will make sure that they can do so. Thank you very much, Robert.
Thanks, Peter. Thanks for having me.